the Moscow Popular Science Film Studios. The fathomless depths of the universe, the realm of great and eternal riddles, the realm of myriads of heavenly bodies, and among them, an infinitesimal speck of dust, our blue planet, the Earth, the cradle of life and intelligence. For millennia, the human mind has been trying to comprehend the origins of the universe, where it is going, what makes it tick, and what is man's place in it. We peer intently into the heavens. But nowadays, we're also powerful enough to reach out and touch it with our fingertips, the instruments of space robots. Another mission to Venus. Even 4,000 years ago, Venus was known to the priests in Babylon and Egypt as the brightest and most enigmatic heavenly body of the night sky. Its flight among the motionless stars seemed incomprehensible, and people tried to read their fortune in the loops of its trek. The priests of the legendary Maya people adopted that path as the basis of their calendar. As centuries passed, the riddles of Venus began to seem less awesome, and it was now watched not just by priests, but by scientists trying to understand the universe. Galileo was the first person to see through a telescope that the brilliant speck Venus was not really a star, but a heavenly body much like the moon or the Earth. More centuries passed. In May 1761, the Russian scientist Mikhail Lomonosov watched Venus pass between the Earth and the Sun. The planet was shrouded in a shining halo. It was thus discovered that Venus had an atmosphere, further evidence of its similarity to the Earth. In the 19th century, scientists continued watching the motion of Venus and its transit across the Sun's disk. It seemed to roll like a dark pea across the shining saucer of the Sun, but optical telescopes couldn't see what was behind the layers of its clouds. We so much wanted to see in Venus a portrait of the Earth in its early youth. With the arrival of radio astronomy and the radar, we've learned more about Venus than over millennia. Radio waves for the first time pierced the layers of clouds and the mystery of the morning star, as Venus is known. They made it possible to find out the lay of the land and the direction and speed of the planet's rotation. Then came the great era of the first contact. Soviet Venera probes landed one after another in preset areas of the distant planet. They reported back to Earth that the temperature of its surface reaches 500 degrees centigrade. The pressure is 100 atmospheres, and the Venusian air consists chiefly of carbon dioxide. But we wanted to know more. And in 1975, Soviet scientists obtained their first photographs of the Venusian surface. Now here's Dr. Roald Sagdeyev, a member of the USSR Academy of Sciences and the director of its Space Research Institute, to tell us about some of that research. The first few years of space exploration, the first planetary probes, gave rise to a new logic of exploration, to the exploration of objects that are new to us by direct space methods.
Спрашивается, для чего тратятся столь большие средства на эти виды исследований? Я бы ответил таким образом. Наши земные науки...
Why are such funds being spent on exploration of this kind? I would answer as follows. Our Earth sciences ensure mankind's existence on our planet because we cannot live without utilizing the Earth's resources. Our principal method has been the proving ground method, the method of prospecting the most promising crustal and ocean areas. Thousands of millions are spent on such research every year.
Можно сказать, что затрачивается многомиллиардные средства ежегодно. И вот, наконец, наши земные науки получают совершенно новый полигон.
But now, at long last, the Earth sciences have got absolutely new proving grounds to find out the origins of our planet, how its atmosphere formed, and how the ecological balance was established. One such proving ground is Venus.
Во многом эта планета формировалась в похожих условиях, но затем почему-то выбрала другой эволюционный путь и является Венера.
Volcanoes are a faint reflection of the fiery font in which the Earth was born. What was its past? Why was it here that life blossomed forth? We don't know for the present, but the whole geological history of Venus is on its surface, and we can study it by means of automatically controlled, unmanned space probes. They are real robots covering hundreds of millions of kilometers deep into outer space, collecting information on their way and delivering automatic scouts to Venus. Inside the sphere crowning the station is the lander for operation on Venus. Venera 13 and Venera 14, for the first time ever, delivered drilling equipment to another planet. They had to operate in incredible conditions, a scorching heat of 500 degrees and a pressure of 100 atmospheres. In addition, it was unknown what sort of ground they would have to drill: sand, clay, granite, or basalt. It was necessary not only to drill the first boreholes, but also to analyze the rock samples there and then, and to transmit the result of the analysis back to Earth. A complex system of pipelines sucked the soil in and hermetically sealed it. The pressure was lowered by a factor of 2,000, and the sample forwarded to an automatic laboratory. Radioisotope irradiation of the sample excited an X-ray radiation of the atoms of its chemical elements. The spectrum thus obtained revealed the composition of the enigmatic Venusian soil. The eyes of the robots had become much keener. The designers had doubled the resolving power of the new telephotometers. They were now capable of discriminating objects half the size of those discerned earlier. The time needed to transmit each panoramic picture had likewise been reduced. Poets once fancied that on Venus, trees have dark blue leaves. Just recently, even scientists didn't know the exact colors of Venusian soil, rock, or skies, and could hence imagine whatever they liked. A set of sophisticated instruments was created to see and explore that planet. They must be absolutely reliable, and therefore each of them was put through rigorous tests in a centrifuge, through vibration, Impact. A special chamber was used to simulate the incredible Venusian atmosphere with its crushing pressure and burning heat. Instruments emerged from it, scorched as if in battle. But they withstood everything and didn't let the researchers down. That was followed by wind tunnel testing, in which it was found that new instruments mounted externally made the lander unstable in descent. So the designers crowned the craft with an ingenious vane, a toothed crown, which reliably ensured the stability of the robot. Then the final test, a rehearsal of the landing on Venus. The lids of the telephotometers were jettisoned. The tests over, the workers began carefully preparing the space vehicles for their flight. Later, they would come to be known as Venera 13 and Venera 14, and their pictures would be rushed to newspapers and magazines the world over. The landers were ready to explore the Venusian clouds, atmosphere, and soil. And at long last came that day, October the 30th, 1981, when Venera 13 was launched. On November the 4th, it was followed by its twin, Venera 14. Their journey lasted nearly 4 months. And then came its last, most difficult, and eagerly awaited stage. Everybody held his breath in the main hall of the Mission Control Center near Moscow. The map of the sky, hanging high up in the hall, was brightly illuminated. The instruments had done a good job. They had studied the X-ray radiation, the interplanetary plasma, the solar wind, and cosmic rays during their flight. 2 days earlier, this probe had approached Venus, and after separating the lander, had continued on its flight. The Mission Control Center eagerly awaited the lander's encounter with the planet's enigmatic atmosphere. There, far from the Earth, everything was proceeding exactly as during the trials on Earth. The landing craft had just been racing at more than 40,000 kilometers an hour. It had sustained tremendous deceleration forces. Its front part had a temperature of 12,000 degrees, twice as hot as the surface of the sun. Then Mission Control began receiving data from the descending craft. Data have begun coming in. They're of good quality. All the instruments have been activated and are functioning normally. New information has been received. The presence of neon has been registered in the Venusian atmosphere. No thunder dischargers so far, but the instrument called Groza is working. Attention. According to the telemetry, the Venera 13 lander has touched down on the surface of Venus. Attention, according to telemetry processing, the tilt of the craft is 8 degrees. Soil is being scooped up for analysis. Thus, in response to commands from its electronic brain, the robot started exploration work. Radio waves soon brought the first picture from Venus. The experts whose intellect and hands had created this miracle were examining new areas of the Venusian terrain. The pictures were still black and white. Then the most exciting thing of all began, photography through a red filter. Then through green. And through dark blue one, but this was pictureless, as blue rays don't penetrate here. This is the way millions of people saw the surface of Venus after a sophisticated optical electronic complex had combined these color panoramic pictures on Earth. The first robot operated on Venus 4 times longer than had been planned. Then the second spacecraft reached the planet. Attention, the Venera 14 lander has touched down on the surface of Venus. Venusian soil is being scooped up. And again, an Earth probe was sending back pictures of Venus. It was now a different panorama, a flat desert with fewer stones and a greater rock hardness. We now know the composition of that rock. The dozens of spectrograms sent back to Earth revealed the contents of potassium, magnesium, silicon, aluminium, calcium, titanium, manganese, and iron in Venusian rock. Two new explored areas were charted on the map of Venus. Meanwhile, the probes continued on their flight, and they too were sending back information from the depths of the universe. They'd become artificial planets of the solar system. We make flights to the planets. We want to explore them in order to have a better idea of history and to foresee the future of our own planet, the Earth. Script, Borisov and Nehamkin. Direction, Ivanov. Photography, Gureyev and Novitsky.